All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we're going to pick up where we left off last stream. And we're going to fix some Dingus-oriented programming. And so we'll get into what I'm talking about here in a minute. Let me just make sure that everything is good to go. I think we are good. Tammin, good to see you. How's it going? All right, so before we jump into any of that stuff, I do want to just take a quick second and thank the supporters of the channel, starting with our partners who are the highest tier of subscription over on Patreon and YouTube memberships. They are Dustin Punt, Gabby Bashir, and Gerboles Inc. I'd also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It greatly helps, and it helps, support and cover the costs of, this project, the channel, equipment costs, things like that. So it's greatly appreciated. Thank you very much for that. And of course, I hope it goes without saying that I appreciate each and every one of you viewers, whether you're catching the VOD later or you're joining me here live on the Twitch side or the YouTube side. We do simulcast to both, so I do have both chats open. I keep an eye on them, and I respond to them to the best of my ability. So this is designed to be an interactive stream, so I enjoy talking with you guys very much. So feel free to jump in, say hi, ask a question if you have one, and we'll go from there. Okay, so Dingus-oriented programming. What am I on about? Well, we've talked a little bit about this before. And, generally speaking, Dingus-oriented programming is just when I've done something that's kind of dumb or doesn't make sense. And sometimes it's not something that I find until way later, like we kind of found at the end of the stream last night. And so that's what we're going to take a look at and see if we can't address tonight before we go any further with the resource management stuff, because there's some things here that I don't feel make much sense. And this is partially because of the way that we initially wrote the Vulkan renderer. This is a little bit left over from that. So I want to just kind of take a step back and take a look at how we handle our descriptor sets, and specifically our samplers for our uniform samplers for our textures and whatnot. I want to take a look at that and see if we can't make it make a little bit more sense, maybe eliminate some code, simplify some things, stuff of that nature. So the way that this works right now is we have this sort of internal function here, which is basically descriptor set update and bind. And so what this does on a high level is it checks to see if the descriptor set that we pass in has data that needs to be updated. And if it does have data that needs to be updated, we go ahead and perform those updates, i.e. upload data to the GPU or set various uniforms, whatever it might be. And then we go ahead and bind that. If we don't require an update of some kind, that we just perform the bind, and that will last up until we perform another bind for another draw call, etc. So that's more or less what this function is doing, and it takes a few parameters if you haven't noticed. So we may actually wind up maybe cleaning this up a little bit as well. So we take some things like the renderer frame number, the pointer to the shader, obviously the descriptor set itself, the descriptor set index, and then what we call a Vulkan descriptor state, which is something that accompanies the descriptor set, which contains basically a generation. Oops, didn't mean to tab down like that. So basically a generation in terms of how many times has this descriptor set been updated, and it contains one of those per frame in flight. And then we have IDs and then frame numbers. So when was the last frame number that this was updated on? And so we kind of have both of these this is another thing that I want to kind of investigate and see if we can't, deduplicate some of this effort here, because we have a generation, and then we have a frame number here, as well, to sort of check when that was updated. And I don't think we need both. I think we can eliminate one of those. So we have that. And then we have a uniform sampler state. And this was sort of what drove the need to kind of look at this tonight. So what this actually holds is it holds a pointer to the uniform itself, so we could extract uniform information from that as needed. But then it also holds a pointer, or I should say an array of pointers to texture maps. And this is really what I would like to eliminate if we can, first and foremost. So to catch us up to where we were before, we're basically taking our existing texture type that we have now, replacing that with a new K-resource texture type. And along with that, all of the additional structures that go with that, we're sort of refactoring those as well and creating new versions of those. Most of which are going to remain exactly the same, but by changing that structure, we'll know what areas of code we've touched, what areas we haven't, and then when we go to remove this structure, that will further help us identify that. So what I really don't like about this design is this texture map then has a generation of its own, first off, but then it also has a pointer to a texture, which we're trying to actually get away from. So I want to see if I can actually get rid of that as well, and just kind of clean this up a little bit and see if we can't get some of this type of data out of the back end, because it's stored in some of it's stored in the renderer front end, some of it's stored in the renderer back end. We've moved some of this stuff before, and I feel like there's some of it that could also be changed. So the other thing that we have is some stuff here about the UBOs, right? So the uniform buffer objects, and that's an offset and a stride. So we have those separate right now, but we also have a range struct that we can use, so I should probably convert that. The number of uniforms that we have, and then we also have an array of sampler states and a count of those. And so there's a bunch of different things here that we can improve upon, and maybe make this not quite so complicated. And so what this function essentially does is, first and foremost, it determines if it needs an update. And it does that by taking a look at the descriptor state frame number, in other words, the frame number that it was last updated on. And it says, hey, if that's not equal to the renderer frame number, then we do need an update, right? If it is equal to it, then we've already updated it for this frame. That keeps us from performing the update more than once per frame, which is not valid, right? So we do that check here. This check used to be on the front end, now it's in the back end, and it really does belong here. So that is correct. And then what we do next is we actually create an array of these descriptor rights. And these descriptor rights are what actually is used to update those descriptors, right? So we do 1 plus the shader max texture bindings. This is just a stack array, so it's not that big of a deal if we over allocate here, because it gets nuked, right? So we do that, we zero that memory. We do 1 plus max texture bindings because we have 1 for the UBO, and then 1 for the maximum amount of possible textures. So we do that, and then we go ahead and take a look at the uniform buffer to see if it needs an update. So we check our uniform count. Whoops, I didn't mean to move that. We check our uniform count, and then we go ahead and check to make sure that that UBO generation is valid, and if it's not valid, that means it's never been updated. We create the descriptor right set for that, etc. Right? So we go through that logic there, and then we iterate all the samplers. And when we iterate the samplers, essentially what we do there is we obtain a pointer to the binding sampler state, and then ultimately go through the binding descriptor count. And this is where that texture map is actually used. This is the only place that actually uses this, right? And we use that map to obtain a pointer to the texture. We then grab that texture's internal data, right? And this is done by reaching out to the texture system, which is weird, right? We probably shouldn't be doing this either. This should definitely not have a reliance on the texture system. So this is another thing we need to fix. And then we do some validity checks here to make sure that the map is valid, right? So we should probably even do that before we try to grab the texture or anything. But then after that, we do a generation check to see if there's a mismatch there. And if we require an update, we go ahead and perform that update. And the reason that we need the map and the reason that we need the texture pointer is all right here. Just for that, right? Just for the image view. And so that's something that we, again, like I said, we could probably simplify. And so I've got various to-dos in here, and so I kind of want to review some of this stuff and see if we can't simplify this a little bit and make it so that we don't have to run these checks every single time, and that we can basically just run these if and only if we actually need them when they've been triggered, and then leave it alone after that, essentially. So I hope that makes sense. I don't know if I said this or not, but thank you for the follow, Degradilla. I appreciate that. Welcome. All right. So the first thing that I wanted to take a look at was how we can eliminate using this texture map, right? Because ultimately, all we're really after, we don't really need the texture map past when we create the initial sampler. The only thing that we really need from that I'm seeing here is we need a pointer to the internal Vulkan image from that, right? And from that, we can actually extract the view. So my thought here is we maybe take a look at this, and maybe instead of in the binding sampler state, instead of holding on to the texture map there, perhaps maybe we just hold on to a pointer to the internal image instead. That may or may not be the right move. We'll have to see. Let's see. I think that's actually all we need in here. So that's basically what we have to evaluate, is how we're going to move this stuff around to fix that. TCAP with a raid of 16 viewers. Thank you so much for the raid. How's it going, dude? Good to see you. What did you get up to on stream? For those of you who are not following TCAP, do it. He's a GigaChad dev here on Twitch. Definitely worth checking out his stream, for sure. Power of 2 raid, yes. That is pretty epic. You can't really argue with that. Trying to improve the profiler. Nice. That's something I need to put into here as a profiler, a proper profiler. Who knows? Maybe I'll steal yours. Yeah, so at the moment I'm actually thinking about how I'm going to simplify my handling of Vulkan descriptor sets, specifically when it comes to texture bindings. Because it's kind of a pain in the ass now. And I've had like fix me's and to-dos in there for like the last 2 years. So it's finally bit me in the butt. Really quickly, for the raiders, if you guys have not been here before, what we're doing is we are building a game engine in C using Vulkan as our initial rendering backend. And I say initial rendering backend because we plan on supporting Direct 3D as well as Metal down the line as well. So this is a cross-platform engine. It works on Windows, Linux, and Mac OS as it stands. It is free and open source. It started as a like a tutorial series, and then we changed formats a few times. Ultimately, it landed on the live stream format, and that's where we are now. So when I say it is free and open source, it is on GitHub. Let me drop a link really quickly in chat to the main website. And the engine itself is Apache 2.0 licensed, which means that if you want to use this, all you have to do is say you used it. That's it, literally. There'll never be any sort of royalties or licensing fees or any of that crap, right? It's always be open source and free. And then also here we have, YouTube, Twitch links, our Discord, which is almost 1,000 people at this point, I think. And then GitHub and Patreon, all that good stuff. So that is all here. And then, of course, all the code is here. So we are in the midst of a fairly large redo of how we are handling our assets and our resources. And sort of in the middle of that, I discovered this issue that I'm actually working on now last night. So I'm going to try and refactor this basically to avoid having to have this texture map structure and the front end texture in this at all. I want to remove these from the equation and just use their underlying resources instead of having to do this, reach out to a different system to get the internal data. Like, this is poop. So I want to get rid of that. And then from there, we should be able to simplify the way that all this works. And that's more or less what we're doing. Couldn't attend last week and lost my 49 stream streak. Oof. Sorry about that, man. It's good that you're here, though, Taman. I'm glad to see you. Trash Can, you got your hands on a Hackintosh, and Metal seems a lot easier than Vulkan, except for the whole Objective-C thing. Although I suppose you could target it in C, I think. Maybe. But yeah, if you look at Metal, actually, and you look at Web GPU, there's a lot of similarity there. There's a lot of overlap. So yeah, I think once I get around the idiosyncrasies of the actual API itself, I don't think it's going to be that bad to pick up. Which will be good because then I can drop Molten VK support, which is fine, right? But it's an emulation layer, which is not great. There's CPP headers. It's kind of ass, but it's there. Okay. Yeah, I mean, I really don't want to do it in CPP if I can avoid it. I'd much rather just use C. So I wonder if that means that I'll have to, like, make our C wrapper for it. Swift seems like a fine language, just don't know how to link with C. I've never used Swift, so I can't speak for or against it. I have done Objective-C. There is some Objective-C in this code base, actually, for macOS. So if I had to do that, I guess I would go that route. And I might be able to mix it like we've done here. Right, so you notice this is a .m file. And so this is mixed between Objective-C and C, which kind of works a little bit better than just having to write the whole thing in Objective-C. So that might be the way that I wind up going, is just do the Objective-C and stuff and then wrap that in C. You do really hate C++. You prefer doing Objective-C than using C++ headers. You're damn right. Objective-C is extremely weird. You're also right. Plus, all functions are called from a dynamic dispatcher. Didn't like it that much. Yeah, no, I don't really like it either, to be honest. I'm not a huge fan of it, but I mean, if I have to do C++, I'll do C++, but I'm hoping that the only time that I have to use C++ on here, on this channel, is for iterators, for a variable called C, and that's it. All right. You gave a suggestion for the texture issue up above. Did I miss that? Let me see. Oh, keep an internal lookup table of all Vulkan resources and grab the ID that identifies it. That's kind of what I'm thinking of doing. And we kind of have that. We actually have that for samplers. And we already do that for samplers. So I think doing that for the internal texture resources is probably going to be, because all this is basically this, right? And the reason that we have this is because we can have a situation where we have to have more than one image, more than one backing image for a single texture, for instances where we have a texture that has to be per frame or per swap chain image, rather. So, for if you're triple or double up buffering, this would essentially have that image count number of images. So a lot of times this will be one otherwise, with just a single one in here. But then there's also ones that have the double or triple buffering taken into account. And this structure sort of wraps that up neatly so that we don't have to worry about that on the front end. That's all completely abstracted to the back end. So I'd probably have to keep like a lookup table of these internal datas, which are currently actually owned by the front end, which I might actually wind up changing as well. I've moved that around a couple of times, but the reason let's see. Where was, so texture internal data. So we have these texture lookups, right? So whenever we need to access texture data, we have a unique ID, right? This is sort of a texture lookup table that exists in the renderer front end. And then that contains a struct, just a generic struct pointer to this texture internal data, which is actually defined in the back end. So we don't know in the front end how large this thing is. So the front end basically asks the back end, hey, what is the actual size of this thing, and then allocates a bunch of them. I'm trying to remember what my justification was for doing that, to be completely honest. I did have a reason behind it, but it's been a bit now. Texture resources acquire. Was this so that we could... See, this is where it gets a little bit weird too, because this is where we started introducing handles to things. This is why I did it. Okay, now I remember. All right, so this was where we actually started introducing handles, the concept of handles, right? Instead of using pointers to textures, we started introducing the concept of handles. So the handle, right, is just an index into some resource array and a unique identifier that's global, right? And so this is what gets returned whenever we create the sort of backing resources for a texture. And the reason we did it in the front end is because all of this lookup logic would be the same for any backend that we have. And so I didn't want to have to re-implement that per backend, right? I wanted to keep the sort of generic bits of it on the front end and then let the backend sort of decide how that internal texture data works for itself. The only issue with this is there's still a lot of pointers that sort of get passed around, which I'm not a huge fan of. And so we might actually wind up replacing this with an actual lookup table that's actually indexed by those handles. What I do on my backend is keep a dynamic array that holds all the resources, and the ID is simply the index into the array. Yeah, which is more or less what this is doing. But we have that front end back end separation. Also for the swap chain 3 thing, it's always the first 3 indices because they are the very first resources created by the backend. So it's not the swap chain images itself. It's based on how many swap chain images we have, aka are we double buffering or triple buffering or whatever. The Mesa drivers for AMD actually use 5, right? And so what we wind up dealing with here is that number can be variable, right? So it might be 3 in some cases, it might be 2 in some cases, it might be 5 in other cases. And we have certain resources or certain textures outside of the swap chain images that have to be 1 per swap chain image, and needs to be synced with that number of swap chain images, whatever that might be. And so that's why we have the ability to do that, and that's why we sort of offloaded that to the back end. So we do have that, but it's like there's more to it than just the swap chain images, right? There's other resources that require that as well. Thank you for the follow, by the way. Appreciate that. All right. So I don't really want to change this too much. The only thing that I really don't like is this bit. But I don't think we have a way around that because we don't know how large this actual thing is without querying from the back end, right? So the back end tells us how large the texture internal data size is. This will vary depending on what the rendering back end is. So for Vulkan, it requires, 1 to X images and a count. Maybe for OpenGL, it won't need that, right? Maybe for Metal, it won't need that either. I don't know. It may need additional resources behind it as well. I don't know. And when I say Vulkan image, the Vulkan image also includes the image as well as its view. Ivan Top Gun, thank you for the follow. Appreciate that. Welcome. All right. So I don't really like the dynamic allocation here. The only thing that I could do to get around this, and maybe this would be a little bit better, is when I stand up the front end, or I should say when I'm calling the back end to be stood up, maybe at that point I say, hey, stand up enough memory, stand up an entire block of memory to hold X number of images, right? Which could be a problem if we ever run out of that memory, but then at least it'll be contiguous. So I'm going to do that, though, because we already have enough to do. So let's put upon backend creation, set up a large contiguous array of some configured amount of these, and retrieve from there. Okay. So this isn't actually what we're after anyways. So let me see. What we're really after is getting rid of this poop. So when let's take a look at this function really quickly. So this get internal or default. Oh, that's why it does this. Okay, this was something else I was thinking about changing too. So our texture system right now has a concept of default textures per type, right? So we have a default 2D texture, we have a default 2D array texture, which is actually kind of poop because it assumes that it's a terrain texture, right? Which has 12 layers, which might not always be the case. So this is kind of a default, but it's not really the kind of default that we need. So that is not really correct anyways. The rest of them are. We have a default cube texture. I feel like that's not all the defaults that we have, but yeah, because we also have a default diffuse, a default specular texture, a default normal map texture, all those things. And because the texture system owns those things, our backend is basically having to say, okay, well, if we're going to go use a texture and that texture is not loaded, it's not ready to actually be used yet, then reach out to the texture system and say, hey, give me the default texture for this given type, which is what this is doing. So that kind of makes sense in a way. But I think the renderer backend should not be what's calling this. If anything, it should be on the front end. So the question is, do we have enough information on the front end to actually do this properly? So if we take a look at what calls update and bind, which should only be like one thing. I think it actually is. Apply instance and apply globals. Oh, okay. Instance level variables and global level variables. Let's see. Global descriptor state is internal instead of the base shader like the instances. What did I mean by that? This. Okay. Oh, I see. It's being stored in the internal shader data instead of the actual like shader data itself. Okay. All right, that's not a big deal. We can change that later. All right, so we are applying globals. During applying globals, which is like our global UBO and our global texture maps, and applying our instance globals and texture maps are the only two things that do this. So when we go to actually make this call, that's when we iterate the samplers and do all of this. We're not going to have this information on the front end. So we have to do this here. Trying to think if there's a way around that, right? So if we only have binding sampler state, we might need to rethink how we're actually storing this in general. So maybe instead of having a texture map that we store it in, maybe we have some other sort of structure where it's stored as part of the uniform. Which actually does kind of make sense now that I think about it. So what we're doing here is we are sampler counts. Here's our samplers that we pass through here. Right, which these are internal, which I could fix that. If we look at the next example of this, we have the instance state, which I think is also crap, that's internal too. So the sampler uniforms is the uniform sampler state. Which is what contains this. So what if instead of doing all of this with these multiple levels of structs and all this stuff, if we put this as part of this uniform texture maps, do we ever have more than one texture map per uniform? Instance texture map. Descriptor states. Per descriptor. Oops. Array length. Set up the array for the, so where does array length come from? Uniform array length or 1. Why do we have So in this case, we are actually doing, this has got to be for texture arrays is what I'm thinking. And or cube maps, where we have like multiple. Oh, I wasn't aware that we were doing it that way, or at least I forgot if I was aware. I think I'm at a point where I either rip all of this out and redo it, or we leave it as is and come back to it another time. Because I feel like this is going to be a long-winded thing if I choose to refactor this now. Let's see. Hey Xerox, how's it going? If you were to choose a game engine as quote-unquote the best, what would it be? What is the best game engine? There is no answer to that, and I'll tell you why. Because each game engine has its own things that it specializes in, and so there is a different answer depending on what you're making. There is no overall best engine, period. It heavily depends on what project you want to make, because, you know, is it 2D, is it 3D? Do you need console support or do you not need console support? Do you need mobile support? Do you need, what type of graphics do you need? Do you want hyper-realistic or do you want just sort of cartoony? Like, all those things make a difference in what game engine you choose. And then, are your requirements super specific that maybe there isn't a game engine out there that meets your requirements? And if that's the case, maybe you need to roll your own, and that's the best, which is what we're doing here. So I know that's kind of a bit of a vague answer, but it's kind of a vague question too. I hope that helps a little bit. Anyways, yeah, so bottom line, there is no best engine. Thing with the CPP wrapper is that it feels like you're using Objective-C with a different syntax, like you have to call alloc everywhere. Ooh. If you keep a global list of all Vulkan resources on the back end, it simplifies cleaning up a lot. Just nuke everything when the device goes idle. Right. Which is what I want to work towards. In Vulkan, do you also have to create a view per usage? Like a render target view and a read-only view? No. No, they're the same thing. The view is just an accessor for the actual image data is all it is. But yeah, I don't need one of those per usage. Is that a direct 3D thing? Sounds gross. I think it's bad enough that we have views to begin with. It's a little crazy to me that we have to have the view object at all, like just allow me to access the texture, but it is what it is, I guess. All right, you know what? I think I'm going to put a pin in this because this is not going to be a quick thing. And it's going to heavily detract from our progress with the resource management stuff. What I'm going to do, so we don't lose track of it though, is I've actually been updating our sort of to-do list here, and I actually have stuff planned out for the 0.9 release and the 0.10 release already. So I'm going to add this to 0.9 for now, and it might wind up moving to 0.10. Refactor handling of texture map, texture resources, and Vulkan renderer. Put that there so we don't lose it. There are render target, depth stencil, and read-only writable views, each with its own heap. Just when I thought Vulkan was the most verbose, apparently Direct3D is trying to outdo it in some aspects. All right. So I guess what we really need to do is all of these places where we have uniform texture maps being set. We need to refactor those, or we need an alternate version of them that uses the K-resource texture maps. And then once we get everything over to the new resources, we can strip these out. So I guess let's do this. We'll do I wonder if I can do K-resource texture map. Uniform texture maps, but I guess I'll have to rename this to uniform K-resource texture maps. And anything that makes reference to this, I'll have to have an alternate version of it that handles that. Kuju rating with a party of 29 viewers. How's it going? It's good to see you. What'd you get up to on your raid? On your stream? For those of you who don't know who Kuju is, he's working on a kick-ass looking game called Fat Goblins. It's written in Jai. And it's very cool looking. So his game's on Steam too. So go wish list it. Added 2 new aiming methods, basically for the newbie people and controllers. Sweet. That sounds awesome. I really like the way that game is coming along. It's looking really good. I lurk whenever I get a chance. I hop in there and lurk. I'm not always able to interact, but yeah, I've been watching your project. It looks really good. Yeah, thank you very much for the raid, though. So I will give just a quick explanation to the raiders as to what we're doing. So we are building a game engine from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because we do have plans to support Direct 3D as well as Metal in the future. So it started off as a YouTube tutorial series, changed formats a few times. We ultimately landed on the live streaming that you see here. We live stream to both YouTube and Twitch. The engine itself is cross-platform, so it does run on Windows, Linux, and Mac OS, and it is free and open source. I already had that tab open, so... it is Apache 2.0 license, which basically means if you want to use it, you are free to do so, whether it's personal, commercial, does not matter. And there will never be any licensing or royalties, fees of any kind. This will always be free and open source. This site here, which I'll drop a link in chat, is basically the homepage for that whole project, right? And it's got the YouTube and Twitch links on it, a Discord link. It's got about 1,000 people in there, GitHub, Patreon, all that good stuff. And so what we're doing right now is we are in the midst of a refactoring on both our assets and resources. So before we had just sort of a resource system that kind of handled loading assets from disk and all that stuff, as well as uploading them to the GPU. And now what we're doing is we're splitting those two things apart, those two processes apart. And we're handling assets and we're handling resources. So resources are basically what winds up getting uploaded to the GPU, like a texture, for example, whereas an asset is something that's loaded off of disk, so it might be an image, for example. The reason we've kind of separated that out is, and this is a good example, is because an image can be used for more than just a texture. It could be used as a height map for a terrain, for example. We've split those things out. We're going to Jobify all of that so that it's multi-threaded. Some of it already is, but now we're going to basically make all of our asset loading multi-threaded. We're going to support hot reloading and all that good stuff. We already have some support for that, but all assets are going to support it if you turn it on. We also wrote a packaging system and a virtual file system that all of that kind of sits on. And so we've done the asset portion of that, and now we're doing the resource portion of that. Part of what we're doing is we're taking all of our sort of old resource types, and we are essentially taking all of these things and refactoring them one by one to only be a resource and not a sort of resource slash asset. And the way that we're doing that is we're basically just creating new structures for each one of those things. And then once everything is converted over, we'll come down here and we'll remove all of these old structures and we'll just have the new ones in place. So we're starting with textures specifically, right? So we have our texture handler here. And that's kind of what we're in the midst of. I did find some stuff on the renderer backend for Vulkan that we need to address because we have this sort of texture map thing which has a texture in it. And now we have this K-resource texture that we're using instead. So we basically just need to swap that stuff out. But I'm also trying to do it incrementally so that we don't break everything. And I'm basically going to switch one thing at a time to use the new texture system and the new resource system and all that stuff. So that way we can kind of test it in bits instead of having the whole thing explode at once. So I hope that makes sense. Have I ever developed a game engine that ran on low-end mobile devices? Yes, and through the browser, no less. So yes. Random question, but do you mind if I message you later and ask some questions about YouTube? I plan to start focusing on YouTube marketing pretty soon. Yeah, go for it. Do you have me on Discord? If you don't, feel free to shoot me a friend request, and I'll accept it so you can DM me there. But yeah, that's totally fine. Yep. What's the biggest performance killer on low end mobile? Memory fragmentation, I would say, and lack of texture compression is going to be a big one. Yeah, memory fragmentation is a big one for sure on any low end device like that. Also, you'll want to optimize things like your draw calls, and then also, oh god, there's a whole slew of things actually. Yeah, that's kind of a loaded question, but yeah, overdraw is a big one. Yeah, there's a bunch of things. There's a bunch of Vulkan specific things, but then there's also a bunch of engine specific things. But yeah, basically you want to avoid memory fragmentation like the plague. Sebastian Altonen, that's a great suggestion. Yep. He's way more up to date with that stuff than I am, because it's been a few years since I've done that. We're going to be eventually tackling that here, but we haven't gotten there yet. Testing on our RPI 5 as well doesn't run well at all. Yeah, no, that's fair. We're going to be experimenting with that eventually, but 10 FPS max, ouch. That's painful. Okay. So the thing that we're going to have here is we have this concept of, let's see, binding sampler state, uniform texture maps, right? So I guess what we can do, this structure now has both of these, right? So we have the K resource texture maps and then the old texture maps. So I think what I'm going to do is if the sampler state was using these K resource texture maps, then this will be the only array that exists, not this one. So we just check for the existence of this one, and if not, use this one. Or I guess we should probably check for the existence of this one and fall back to this one if we're not using it, right? And then, so I guess we can do T generation. This internal or default is something that's going to have to change too, but I'm going to skip that for now, which may actually wind up biting us, but we'll find out. So what we'll do is if binding sampler states K resource texture maps, then we're going to do one thing. Otherwise, we're going to do this. Let's see. I guess all of that, but I don't really want to repeat that a bunch of times. So, image index, texture internal. Okay, that's this. All right, so I guess what we can do, let's take this and stick it up here. Right, and then here we can do that. Take these back out of here. Those need to be here, because we need to update those no matter what we do. Samplers map internal ID. Crap. So this is what pulls from our samplers array, but that's also based on the texture map, which I didn't realize until just this second. So this is just a flat array of samplers that's indexed by the map's internal ID. which, do we have that on our other texture type? So let's do k-resource texture map, and we'll call this map2, sure, why not, equals binding sampler states. K-resource texture maps sub D. And then we're going to want k-resource texture. We'll just call this T equals map texture. Right, so it's kind of, it's very similar, but it's not 100% the same. Now we don't have, I don't think we have an equivalent of this, which I'm not huge on, honestly. I would really like to move the internal or default to here, I think. Or at least the renderer front end, in terms of like default textures. I realize it kind of makes sense for the texture system to have it, but like I feel like the texture system relies on the renderer, but the renderer probably shouldn't also rely on the texture system. That's a little bit strange. Let's put a to-do here. The renderer should not rely on the texture system. So probably what we should have is these default textures created, I guess, when we stand up the renderer backend. Or maybe when we create them, we can pass some sort of flag along with the texture to say, hey, this is a default texture. Go ahead and save this off to some internal lookup table for later reference. Background song is lit. What is it? This is City Ruins off the Nier Automata soundtrack. Let's see. Can I grab a link to this? I don't think it does really. There we go. Copy song link. Give me a second. So this is that song. Ever planning to port the engine to consoles? Yes, I do have plans for that. I do eventually want to port it to Xbox. I'd like to port it to the Switch as well. The problem with that is those portions of the code are not only going to not be able to be free, but they're also going to, they're not going to be able to be open source, right? Because of NDAs, which is where that the complexity of that kind of comes into question. So the issue there is going to be anybody that wants to use it is also going to have to sign an NDA and be approved by the manufacturer of that console to actually use it. So that gets a little bit complex in terms of licensing and stuff. And that's out of my control. I can't control that. That's up to them. But yeah, that is the plan eventually. We do want to support consoles eventually. Probably not until we have a few releases, right? A few games out on desktop. PlayStation maybe too, yeah. We'll have to see. That is the hardest one to get, I think. The thing is, in order to get that, you have to have a certain number of unit sales, I think. Planning to make a ray tracer? Eventually, yep. Hardware accelerated ray tracer, yeah. All right. We're going to have ads here in just a second, actually. So I'm going to be pausing the stream for that so that nobody misses anything. Twitch is telling me that's coming up here just in a moment. So, And there they are. And for those of you who can still hear me, take this opportunity to go ahead and hydrate. It's always a good thing. Stay hydrated. So we've got about 50 seconds left on ads. Almost done with ads. All right, cool. Ads are done. Let's see. How long do you think the engine would take to make? So I am doing this by myself, part-time. And I would say part-time at most, right? Because like, I don't think I'm actually able to put 20 hours a week into it. But yeah, I've been at this about 3 years so far. It is starting to ramp up and pick up though. With the streaming, it is a little bit more fast-paced than it used to be. So I'm going to say I'm hoping to have everything buttoned up and start actually developing a game with this, at least our first simple game, within the next month or two is what I'm hoping. Which is probably going to involve lots of us going back to the engine for the first game, to be honest, right? We're going to have to do that back and forth a lot of times. But yeah, that's kind of what we're looking at. But the engine's never really going to be finished. We're always going to be adding stuff to it, right? So there is no finished as far as the engine goes. Also, any advice on how to get better at structuring code or designing it? Practice. Learning what works, what doesn't work. Looking at both good and bad examples that you read about and see online. And the reason I say bad examples is because then you can look at them and think critically about why it's a bad example, right? So yeah, I would say, look at other game engines online that are open source. Look at books about it, right? But a lot of books are also going to punt object-oriented programming pretty hard, which isn't always necessary also. So just bear that in mind. How were your first few game engines? Rubbish. Yeah. Your first few are always going to be bad, and that's okay, right? I've written dozens of game engines on my own, like hobby engines, just to try different stuff and see what would work, and then I throw it out and do another one. Which is kind of where I've come up with, a lot of the ideas that are behind this one. It's just from trying different things. And you're going to try a lot of things and those things aren't going to work, and that's okay. Throw it out and do something different, right? Don't be afraid to throw out your code. Actually considering starting streaming development of my engine just to keep me motivated to work on it. Tamit, if you do that, I would totally watch. Assuming you don't stream at completely insane hours. But yeah, I would support you on that for sure. Does game engine architecture push OOP? A lot of times, yes. All the major game engines out there do it. So yeah. And I just, I say, it's not necessarily always bad, right? But like challenge it whenever it comes up. Think about, do I really need it here? Sometimes you do. Sometimes that's okay. But I would argue more often than not, it kind of gets in the way. And I still struggle to break some of those habits myself. So we have pretty similar time zones. you're only 1 hour behind. Okay. So if I'm an hour behind, then you must be on the East Coast then, right? Of Brazil? Yeah, okay. That makes sense. All right. Thanks so much for your continuous help when I ask questions. Yeah, no problem. That's the purpose of the stream, right? It's a educational thing. So as long as it's kind of related to what we do here, I'll answer it to the best of my ability, right? Sometimes if it's like too deep of a question, then I'll be like, yeah, maybe we should take it offline. But I try my best. Okay, so what we're looking at here is we have this this sort of check to see if we're using the new type or the old type. The next step of this is like we have this lookup from the texture system to say, hey, get internal or default. And it returns the pointer to the internal data for either the texture that we pass it, which would be here, or the default texture if it's not loaded, right? So we've got that pulled up here. And basically it takes a look at the generation and says if the generation is invalid ID, then we go ahead and we check next to see if the texture that we're actually returning or the texture that we're checking is already a default texture, which is a default texture is basically a lookup of is it any one of these, right? And if it is, it's just going to use that. Actually, yeah, if it is a default texture, it's just going to return that, right? And default textures are always loaded by default. By the time we get to this point, the default textures are always loaded because they're loaded whenever the system is first stood up. So we can always depend on those being loaded. And then we have a switch here based on texture type. And this then looks like it overrides T and then goes ahead and gets the texture handle from that, reaches out to the renderer and does this, right? So I actually am going to say that we could actually simplify this function to completely remove the need to even take in this texture, right? So what we really need is the texture generation, the texture type. And actually, it looks like that's it. What does is default texture check? I think that goes against the name, right? No, it literally is a pointer comparison. Okay. So, So the only thing about that, and default textures are actually going to be a little bit of an issue too, right? Because those are the old type as well. Which means we're probably going to need to stand up default textures of the new type as well. And we don't have those. I'm going to pretend like that problem doesn't exist for right now, and I'm just going to move on. I guess the simplest way to handle this for now would be to duplicate this function. As much as I hate that. Yeah, I think that's what I'm going to do. And eventually all these functions will wind up being marked as deprecated anyway. So let's put this one below here. And we're going to say texture system, get internal or default. Let's do texture system resource, get internal or default. And this is going to be K resource texture, right? We're going to take that in. And then T does not have a generation because that is part of the base. And I think that's a 32-bit. Yeah, so this should just be invalid ID. Okay, so now we're checking to see if this is a default texture, which we don't actually have a concept of for the new stuff. So I'm going to put a to-do here. Default textures for a resource texture. And I'm going to comment this test out. Let's do that. Let me stuff a new line in there just to fix my highlighting. Okay. Now what this is doing is this is actually returning our default texture for the appropriate type, which is fine. But the thing is, ultimately we need the handle. So I guess let's go up here and let's do khandle, and we'll call this text handle, and we're going to set this equal to t base, or was it actually not in base? No, it's render texture handle, right? So we'll default to the render texture handle of this guy. And then otherwise, if we use one of these default ones, instead of that, we're going to do text handle equals, and then we'll do this, render texture handle, right? So that way we don't have this weird stuff happening here, right? And then we can do text handle right. Set the actual texture generation. So if we're using a default texture, we don't have a way to check to see if this is a default texture. So if we were doing this, since using a default texture, wait a minute. Oh, okay. This is, okay. So this text handle thing actually needs to be, this needs to be moved up here. Right, and actually, well, I suppose we could actually, we could actually just do this. Default to that there, override it here. And then instead of using T render texture handle here, we would do text handle, if I can type it, for whatever texture we selected. And then the generation would need to be base generation if we're using that, right? So that's going to be, that's a U32. I think this is a U8, which is wrong. So this needs to be U32. And that is basically the new equivalent of that function for now. Not 100% sold on that, but it should give us what we need. So we'll put this here. All right. And And then we can go back to here and do essentially this same step, copying our to-do, except we want get resource. I think it was resource internal, wasn't it? What was it called? Texture system resource get internal. That's what it was. And T generation is going to be a U32 in this case. Right, so we pass through T. All right, so we have that. All right, so then we do some validity checks to make sure that the texture is valid. So this is basically determining whether or not we're using a default texture. So part of the reason that we do this, and we flag this way anytime we're using a default texture, is technically whenever we're using a default texture, we check the next frame anytime we bind that to say, hey, is this still default? Is this still default? And if not, then we go ahead and update the texture. And so the only time we use a default texture is if a texture isn't loaded yet or it's not available to be loaded. And then we'll use a default texture. But this kind of gives us a way to keep rendering the thing without actually having the real texture loaded because we can use the default. So unfortunately, this is going to wind up also having to be duplicated, I think, because T generation is a different type. So yeah, I'm going to have to duplicate this. And again, all this duplicate stuff is going to go away once we get rid of the old types, right? Map generation. Okay, so sync the generations. So this is a U32. What is it saying? Oh, this needs to be base generation. Okay. And then Vulkan renderer texture map resources refresh. So this is going to be another thing that we're going to have to modify. Ooh, and this is an externally facing one. Right, but we already created this. Sweet. We already did that last stream. All right. Okay, so that was K resource texture map. So that should just be that. Okay, all of this should be fine. I just need to change these to U32s. Oh, it's just invalid ID actually. Okay, I think the rest of that is good. So we have image index. Okay, so this part can actually be split out. This doesn't have to be duplicated. This can go down here after we figured all that out, I believe. Texture internal. Yes, so this can actually be moved here. And I guess we'll also default that to 0, right? And then down here, we could just set that, right? And then further down here, we should have what we need. Yeah. Okay. So that way, no matter what struct we're using, we should be able to do the thing correctly. The only other bit that we have to fix is this, which is talking about undeclared identifier map. So those both, I believe, have an internal ID. think the new one has it too. Yes, it does. So what we could do is we could just lift that up to here. We'll do, I guess we'll do map internal ID equals invalid. Whoops. Equals invalid ID. Right, and then here, let's see. This is using the map internal ID either way. Okay, so we could probably do that. Map internal ID equals that, and then copy pasta this down here. And then here we use map internal ID. Okay. So we do still have this item to worry about in terms of relying on the texture system. I still don't like this, but that's going to be something we're going to have to move later. Did we catch everything in here? I think we did. All right. I see there's a warning in here somewhere. It's not used directly. Okay, let's get rid of that. Just get rid of that warning. Okay, and that I'm not worried about just yet. Okay, so that is that use of uniform texture maps, which is probably the usage we're most concerned about, right? That's where it actually gets used. Everything else is assignment, I believe, or destruction. So the next thing we have is instance resources acquire. And so this, we need some sort of way to indicate what type of texture map we're going to use, right? Because this is using the uniform texture maps here, but we also need a way to tell it, do we want to use this one instead? I don't think we should vary this by individual sampler. I think if we're doing it for a shader in general, it should always be done for that. So maybe we have a flag on the shader itself that tells us this. But I believe this is also where we have an instance resource config. So maybe this is actually where we can do it, because I think we have this uniform texture config, right? And then this has texture maps in it. So this is probably where we're going to make that distinction. We're going to say U32 texture, let's say K resource texture map count, and struct K resource texture map. That's going to be a pointer to that, and then we'll do text. Let's see, K resource texture maps. I guess I could just say maps, but all right. So if this stuff exists, we'll use that. Otherwise, we'll just fall back to this same kind of pattern we were doing before. So let's see. Array length. And then this is the actual config. So texture config here. Okay. So technically speaking, all of this stuff that's highlighted here is going to have to switch on this. So I guess what we could do is we'll say if because technically we have that information is at this level, right? Which makes this nice and easy, but not this. I guess what we could do, this seems kind of a little bit poopy, but it'll be a little bit easier to follow this way. Put this here. Turn that off for now. And we'll say if I need, oh, wait a minute, TC. No, it's right here, actually. Never mind. Undo that. We'll do if TC k-resource texture map count and TC k-resource texture maps. Then we'll do one thing, otherwise we'll fall back to this thing. Right, so if we do this, then we'll do this. Spelled resource wrong. Okay. So we'll switch on that, and then we'll do the same thing. Or I guess I could just save off a Boolean, right? B8 using k-resource equals this. Right, and then down here I can do the same thing. So I could say if using k-resource, do one thing, otherwise do this as a fallback. And this is mostly going to be the same, but looking elsewhere. Right, so this is going to be that. Incompatible pointer types, yes, because this should be k-resource texture maps. And then we have default texture here. So what is default texture? Texture system get default texture. Okay, so that's going to be an issue too. I think we might have to address this default k-resource textures thing. I don't think we're going to get around that. I think we're going to wind up having to do that. This is misspelled. Pat S2, how's it going? Good to see you. You here just refactoring the interpreter that you're having AI create. Nice. Brazil doesn't have a West Coast, but yeah, I'm on the Atlantic Ocean side. Yeah, but I meant like East Coast versus like west side of Brazil. Yeah. Lurking for the Dingusness. I love it, Dingus Dev. It's awesome. Glad to see you here. Yeah, we do Dingus oriented programming here, so you should fit right in. All right. So we have this. I guess the only other thing in here, I'm gonna have to come back to that let me search for the other usages of this. Right, so we're going to have to do, we should be checking this anyways, if sampler state uniform texture maps. We should be, right? And then we should be doing the same thing. Was it not? Uniform k-resource, there it is, that's that, okay. Right, so we should be doing that. And I actually just realized we're not setting the count, are we? Sampler states. Or is that a D array? It might be a D. No, it's not. But it's always times array length, which I believe we are actually. Yeah, all right. I don't need to worry about that then. Okay, so next usage is going to be sampler state try set. So this is going to be, I think, the last place where these are actually used. Yes, because then we're back there. So we're going to need an alternate of this guy that takes in the other type of texture map pointer. You're having AI write an interpreter for a C++-like syntax language. It's going better than you expected. Interesting. Still insanely bad coding practices unless you specify not to do something. Yeah, I can only imagine. I've never actually gotten AI to generate code that I could ever use. Like I've tried, but there's always something wrong with it. I'm just like, it's either just absolutely terrible for organizational purposes or naming at the very least, but usually it's full of like bugs and memory leaks and stuff. So yeah, I've never actually been able to do it. From Lake, good to see you. Late to the party, anything cool I missed? No, I just, I found out, I was kind of mulling over whether or not I was going to refactor a lot of the Vulkan stuff having to do with uniform texture maps. And I chose kind of not to, and I'm going to kind of hack it for now because it's going to detract too far away from the resource work that we're doing. So I'm kind of hacking the renderer backend for now, and then I really need to do like an overhaul on that and change the way that resources are kind of managed in the backend when it comes to texture maps. Because we really shouldn't be having to pass that structure through at all, I don't think. But yeah. Okay, so sampler state try set. Okay, so there's only 4 instances and they're all right here. Oh, okay, it literally just calls this whether it's global or local. Okay, and it's just varying on what array information it's passing through. Okay. So map is texture map value. Ooh, okay. So this actually is going to have to be refactored first. So if we are doing a uniform set, and that uniform that we're setting is a sampler, then our value that we're passing through here is assumed to be a texture map. The problem with this is now we cannot actually make that assumption. And the reason is because we could theoretically pass through either a texture map or a k-resource texture map. because this is actually technically used for any type of uniform, right? So we have all these other possibilities here. Methinks that I wonder if it would be better. This is another one of those instances where it might actually be better to have like type safe versions of these split out into different functions. And I've been thinking about this for a while, but I just didn't want to pull the trigger on it because it's annoying. All right, so when I call this from the renderer front end, what would I then be able to use to tell me what I'm actually trying to set, I guess? Samplers. I guess what I could do is I could wait to perform the cast until we get in here. To check this array. Sampler tries. Yeah, okay. So I guess I could do we could do this, right? Instead of doing map, right, I could just pass value here. Get rid of this. Let's see, that's a const void. Okay, so we need a const void. That makes sense. Okay. And then here we just do if su k resource texture maps. Then we do that. Otherwise, we do this. And we can take the same check, put it down here, do that. And then here we can do su uniform k resource texture maps subarray index equals, and here we can just do k resource texture map cast value, whereas here it'll just be texture map pointer value value, right? So if we do that, then we'll have, oh, wait a minute. Yeah, because this one should be uniform k resource texture maps. There we go. Okay. So here we can just check to see the array at this level. And then we don't have to worry about that at this level or anywhere else, really. If we just wait to perform the cast till we get in here, then we're fine. Okay. So does that actually, texture, I want search. I do believe I think we've gotten everything as far as that goes. All right, so from that standpoint, we should be good to go in terms of setting and usage. See if I screwed up anything in the build. Okay. Incompatible pointer type. Oh, right, the default texture thing. Right. Okay, 3082. Right. So we don't have a concept of default textures. 4K resource textures. So I guess there are two ways we can go about this. Let me see, what was this actually doing? So this is kind of what I was talking about like how we're storing the texture map, right? We're storing the texture map because it has a pointer to the texture, when all we really need is that internal data. Like if we just stored the internal data, we wouldn't even have to differentiate between these two types, I don't think, at all. So like part of me wants to say, get the internal data get the default texture, then get the internal data for it. And then that's what we store here or here. But I think this also, whoops. That's the destruction. So there's where we set the actual texture map. That's called from the front end. I really do want to get rid of texture maps out of here, because having to do this in either case is not great. I would much rather deal with just the internal data at this level. But I guess what I can do for now, just to get this working, is I can do that. Right? And then in here, right, we do that. Return pointer or null. Let's see. Thank you for catching that, Spiro. I appreciate that. And I appreciate the hydrate redeem. Thank you for that. You have to subscribe to the AI services to get actual results. Definitely full of bugs and memory leaks, 100%, but you have to make the AI aware that it did that and fix it, and it does work. I suppose it's fair enough. I don't know. I'd rather write the code myself, I think. But maybe that's just me. Let's see. So in this case, we don't actually have a proper thing to return here. So we do have like our default texture that we create, which is here. And I suppose we'll need like alternate versions of this, right? So we do k-resource texture, and then default k-resource texture, right? And then default texture. Is default texture. Probably need to do that as well. Okay, so I guess here it would just be default k-resource texture is what we'd use there. And then as far as the creation for that, create default texture. Right here is where we would do that. So the process of creating this should actually be relatively the same. But this actually leads to a good question about our resource system. So how do we then, I guess if we request a writable texture and then write data to it, that would be the way that we would do that here. So we have create default texture. I really don't want to copy all this stuff because all this stuff is going to be changing. So I guess let me do resource system, or k-resource system actually. We'll do a request. We'll have to get the state for that. So k struct k-resource system state. Right, and this is going to be engine systems get k-resource state. Name. So I guess we would do here, we would do k-name create. And to that, we would pass default texture name. The request info, we need to fill that out. So we need a k-resource request info. Right, we'll pass the address of that. And then the out resource in this case is going to be the address of state default k-resource texture. And we need to check this whole thing to make sure that the request went through correctly. And if it didn't, bleat about it. Failed to request resources for default texture, I guess. Wow, I completely butchered that spelling. Okay. So we have that. right? This wants a generic resource. So we'll do k resource. We'll just cast this. Okay. And then we need to request the resource info. So we'll do info. We don't have any assets, right? So that's going to be we don't want anything in there. Let's be safe here. K0 memory. Address of info. Size of K resource request info. Right, let's zero that out. Info. So we have listener instance. So we actually need to, I think we need, we need the actual type for that. Which we can pass through as this request info. Info dot texture type is going to be .2D. Array size is going to be 1. And flags is going to be, let's see, we'll do resource text flags, and we want a writable texture. Okay. So that should pretty much like immediately give us like a writable resource. The only thing that's going to change about this is we're then going to have to pass some sort of like context/listener info. And then we're going to have to upload this data in a separate pass, which we created that on the stack, which was the smart way to do it. But because we have to remember this is an asynchronous request, right? So we actually have to pass like info base, right? We don't have any assets for this. The resource type, we do need to fill that out. So that's going to be K resource type texture. So we need a user callback and a listener instance. So the listener instance could be like a pointer to the texture system, for example. I'm thinking we're probably going to need something a little bit more robust than that, because technically what we're going to need is we're going to need a way to say, okay, after this request has been fulfilled asynchronously, right, we're going to get a callback invoked to a function that we still have to create. And at that point, we need to take this pixel data and upload it to the GPU. So we're going to need to take a copy of basically all of this. We're going to need that. We're going to need a pointer to the resource. and probably a pointer to the texture system state, maybe. So we're probably going to need a structure to hold that data. Pass that along as the listener, and then create a function to actually do all of this once that listener is called back. All right, so let's see. Let's take a look at I'm going to grab this function definition. And I guess let's put the callback function like right here. That should be fine. So what we want is a static function, which in this case is going to be named. I guess we could say default resource texture loaded. Let's say K resource, right? So that's our callback function. So we can put that here. Right, and then our listener data. Let's go ahead and say typedef struct, and we'll say default texture listener data, I guess. Right, and so that will, actually we don't need a pointer to the resource because we have that here. So we don't need that. We will need the pixel array, which is just going to be a U8. So I guess we'll take a copy of that, right? Pixels. And then U32 size. And then I guess we're going to need like all this other information too, like dimension, U32. We want dimension, channel counts, which doesn't need to be a U32, but whatever. Pixel count. Do we need pixel count, or is that just used? That's just used to generate the size. I think that's fine. Okay. I guess that's sufficient. So let's put a note here. We'll say create old style texture and request new resource texture. So it's explicit what we're doing. So I guess we need this. And because this is asynchronous and we don't know when this is actually going to get called back, right? We can't rely on the lifetime of any of this stuff. So our actual listener base listener instance is going to be kallocate size of that thing, right? And we're going to say memory tag texture, because that's what we're dealing with here, right? And I guess what we'll do is we'll say default texture listener data listener equals cold cast info.base.listener, right? And now we can do listener pixels equals, we're going to have to take a copy of that, aren't we? Yep. So kallocates, the size is going to be this. Memory tag texture, right? And then copy memory destination is going to be listener pixels. Source is going to be pixels. And size once again is going to be, actually, you know what? Let's take this. Let's cut this out of here for a second. We'll do listener pixel array size equals this. Right, we have to fill that out anyway. Then here we can do, then here we can do pixel array size. And we can do pixel array size here as well. Listener pixel array size. There we go. Okay, so we have that. We want dimension. And channel count. All right. So we have all that stuff set up. So now that should get passed along when we request this. Once that resource is considered loaded, meaning assets have been loaded, this, I guess, is where we're actually going to have to perform the actual texture upload. Which I would much rather that the texture handler do this for us. I'll mark that as a to-do. Because now that I'm thinking about it, like our resource handlers for all of our different resource types should be able to take in like a list of assets that are required for that resource, but they should also be able to take in like raw resource data to be able to actually load, which it doesn't currently do. So that was something I hadn't considered. That's something we should probably add to that. So I'll put a to-do for now. We'll load it here just to make sure it works, and then we'll move that over afterwards. Okay, so we need to do at this point. Will we have requested resources for this? Actually, I don't know that we would have. Let's check. We'll look at this guy. So this k-asset onResult only gets called if we actually have assets. So that is a slight design flaw that we have here. If we don't have assets, which we're not going to for this, then we're probably also never going to get the user callback. Which is not. which is where all this stuff is. Yeah, now I'm actually kind of thinking we should just fix this in here instead of having it load here, which may mean that we don't even have to do any of this. But if we pass, let's see. So our listener data for this is going to have this information, but what if our listener data had some sort of like standard texture listener data for that? Or technically speaking, it wouldn't even be in the listener data. It should actually be in the request data before we even get to this point. So our base request info is what can have like our assets and stuff, right? So that's what has the list of assets here. That's what holds the user callback. That's what holds the listener instance. That's what holds the resource type. And then this is all the specific stuff. So I'm actually thinking we have texture type array size, which is the texture array size. And then we have flag bits. So maybe I could include something here that actually gives us this kind of information. And then we don't have to do it this way. I think that actually makes a lot of sense. So the only thing we'll have to determine is how do we differentiate whether we use that data or we use the asset data? And what do we do if the user provides both? Because users can do that. Which technically speaking, if we have a multi-layer image, isn't necessarily an invalid option. Let me think about this for a second. So there's a couple of assumptions that we've made that I'm now actually questioning. So when we request a texture, we are making the assumption that the list of assets that we provide here is equal to the number of elements in that array is equal to array size. But that might not necessarily be true. So consider maybe the use case of, let's say a user is trying to load a layered texture. Maybe layer 0 comes from an asset. Layer 1 comes from like raw pixel data from somewhere, and then layer 2 is also an asset. How do we handle that? We can't handle that at the moment. Because we don't want to just hand them like a single array layer of potential pixel data here, right? It would technically need to be the same type of size, right? So like now I'm thinking, maybe I'm overcomplicating this or overthinking it, but I don't think so. Because I could see a case where a user might want to do that. So the list of assets to be loaded. each one of those assets contains asset name, package name, and asset type. And I don't think that we have. We do have an unknown asset type. So maybe if we were to support that situation, maybe the way that we would have to configure this is say, create a array close this thing and I didn't mean to. So create an array of assets that is equal to the length of your array size here, right? So maybe we say that that should always match. And then we can also say that we can have an array of pixel data that needs to be the same as your array size, right? If you're going to use it. If you're going to use it, those array sizes need to match. If you do that, then as we're iterating through, we could check the asset index at that index and see if it's undefined, unknown, whatever that was. And if it is, try to fall back to pixel data. Or, I mean, we could do it the other way around, right? But then as we're going through the layers, we have either one or the other getting used. And if there's a mismatch on the size, we bleat about that right away. I think that makes sense. All right. All right, I guess what we can do where do we actually create? Not that one, base. We create that here. Do the array type here. All right, so maybe we do a new array type with something like this. Right, we'll call it something different. So we'll say like k-resource texture pixel data, I guess, right? We'll do pixels, pixel array size, dimension. We should probably do width and height, right? Because it's not necessarily always going to be square. For our default textures it will be, but not necessarily for here. Let me get rid of this. So we create an array type for that. Trying to think if there's anything else we need there to load that. So we're already going to have the texture type. We have texture flags. Array size. I think that's all we need. Maybe meb levels. But I'm going to roll with this for now. So let's do a array k-resource texture pixel data create. Or no, just the array itself, actually. And we'll do pixel data. And let's add some comments here. So optionally provide pixel data per layer. must match array size in length. And then only used where asset at index has type of undefined, right? So we have that. And then we can just pass that data along in the request. So with this, I don't even know if we need listener data and all this stuff now, actually. So I'm actually just going to do I'm going to copy all that out for a second. This too. Because I don't know that we're actually going to need any of this. Because in this case, we can do info pixel data equals k resource texture request info. Whoops, that needs to be array. Creates length in this case is going to be 1. Right? I guess we could check pixel data first, right? Maybe we should default to pixel data instead of assets. And if pixel data is provided, then we'll use that first. If not, then we'll fall back to an asset. And if there's nothing there, then we're going to slap the user. I think that makes sense. Okay, so let's do wait a minute, not info pixel data, that's wrong. No, that's right. Okay. K resource texture pixel data pointer. We're just going to call this px, and that's going to be the address of info dot pixel data sub 0. Just a little convenience pointer there. That way I can do px. Wait a minute. I need data. There we go. Okay, that's right. So px pixels is equal to this. Actually, you know what? Maybe I'll just do this. I'll grab. Let's do this. And then we have, let's see, pixels. Pixel array size is that. This is going to be px. Width and heights. Channel count is channels. That's it. Okay. And then we copy 2 px pixels from pixels and use px pixel array size. Okay, so we're still taking a copy of that array, but now we can actually pass that as part of the actual request, which makes a whole lot more sense than what we were going to do before. So I don't even think we need this anymore, quite honestly. I think we can get rid of that. and just do this as part of the request, and then do and then in here, let's see. So assets required is false in this case. Okay, so if not assets required, or actually, I guess what we really want to do is we want to say actually, how do I want to handle this? So we're checking the we need to check first to make sure this array actually exists, right? So we'll say if info assets data, then we can do this stuff. Otherwise, it's going to cause a crash, right? And then if we don't have data, then we'll expect pixel data. So else if info, let's see, I think I need typed info, typed request, pixel data dot data. So if we have that, then we can iterate through that. So this is actually going to be info pixel data. Typed request pixel data. Typed request pixel data. There we go. And this is going to be k-resource texture pixel data. Let's call this px again. We don't want this, right? So this is in the instance that we don't have any assets. If we do have assets, then we also need to check to make sure that the current asset has a type. So if asset info, dot type equals type, image, then we'll do this. Else if asset info type equals k asset type unknown, this means load pixel data, right? So in this case, we'll do we'll have to do this without one of our fancy iterators. But we can do typed request pixel data dot data sub, and then we'll do it position, and we'll take the address of that, right? And then that's how we'll get our pixel data for that. And then at this point, we're basically going to perform a direct load of that data, which is essentially going to be this, right? So what I'm going to do is, let's do this. Let's copy that up here and see what we need to actually fulfill this. Renderer. So in this case, do we actually have I think I'm going to have to do, I'm going to have to do this. So we'll grab this. I guess we'll do it up here. All right, so that's the renderer. All right, so listener typed resource. Renderer texture handle. Okay, so we don't need the listener. We have the typed resource already here. Texture data offset is going to be 0. That's fine. All pixel size and then all pixels. Okay, so this is going to be px, pixel array size, and px, pixels. Right? And then we have, so we'll write out the actual texture there. And then to bleat about the error, we just need the name, which is that. And that's it, I think. Yes. Okay. So we write that texture data and then we check the result. So now this is kind of done in line, right? So we can actually take this same logic and put it here. And now if we provide pixel data as part of the request, it should just automatically load it. Which makes this relatively seamless. So all we really need is this. I feel like that could be a little bit cleaner, but it's not terrible. I'm not mad at it. Okay. So we have a default texture. I don't think I pointed the Vulkan backend to use it yet. Nope. 3082. So this needs to be get default k-resource texture. We can't do that in all circumstances, though. Okay, let's undo that and do, oops. Defaults. K-resource texture, and then this is going to be K-resource texture. And then down here, we can do default K-resource texture. Okay. SUI text box. Okay, that's not terribly surprising. However, we're going to cover that in the next stream because it is late and I have to get up for work in the morning. So let me just catch up on comments really quickly. I've been playing a lot of Cyberpunk 2077 lately. Fantastic game. Do you know what the female characters have, what your engine doesn't? Yes, I'm pretty sure I know where you're going with that one. Just trying to see how far I could push it into a halfway decent working interpreter. Yeah, it's a good experiment, for sure. All right, let me do... Oh, thank you for the follow. Or I should say the subscription over on the YouTube side. I appreciate that. Okay, so let me... So that's all the stuff that we are going to update. Gets, commits, work in progress, texture resource, handler. Yeah, that's fine. And I'll push that up so you guys have access to all that good stuff. Okay, cool. So, with that said, let me find somebody to raid. Oh, hang on a second. We're in the middle of an ad break. All right. I'll wait for ads to finish and then... I completely missed that ad break. All right. So I've gone ahead and pushed up that code so that you guys have access to it if you want. I may not understand what you're doing, but I enjoy your content. I appreciate that. Thank you very much. Have a very good weekend. You too, from Link. I'm going to find somebody to raid, and I'll drop a link over on the YouTube side as well. Let's see. And I'm going to make this a relatively quick search tonight, and if I don't find something pretty much immediately, I'm going to... Let's see. Okay. You know what? I am going to do... We are going to raid Alvea Sanctuary. It's a non-profit animal rescue for all sorts of exotic animals that can't survive on their own in the wild for various reasons. And it's a really good thing that I like to support every once in a while. And so just by us rating it and giving them more viewers, it helps cover the cost of that operation, which is very expensive. So I like to support that whenever I can. So that's what we're going to do tonight. I really appreciate you guys being here on both sides. And we'll see you guys in the next one. So thank you guys, and I'll see you later.